Thank you everyone for joining. We're going to get started. Trusted access in an unsecure world. We're going to be covering a couple of different techniques and tools for single sign-on and kind of how they work. And ideally going to do some live demos here that kind of show off how you can work with some of these protocols and get a better understanding of what they do and how they work in your environment. I'm Joel Rennick. Hello, Director of Jamf Connect. You may know me from Nomad and a few other applications that are out there. So we won't be talking specifically about Jamf Connect today, but we will be talking about technology and protocols that Jamf Connect can use, in addition to some other things. So before we start off, we're going to get into some basics, just kind of a little bit of a level set on some authentication pieces. And then the two major topics we're going to concentrate on for this session are going to be OpenID Connect, and how that works with applications, and then also Fido, Fast Identity Online, something that you may have heard a bit more about recently, beginning some traction, which is some good stuff. All right, without further ado, let's get into some of the basics here. So in the beginning, if you go back to the original, no, we're not going to go back that far. However, we can start with Active Directory. If you've been around in the Mac world specifically, but in the Apple world generally, you've probably run into Active Directory and had some sort of interaction with it over the last couple of years. Active Directory kind of really came out in 2000, or at least with Windows 2000, which shipped around the same time. Heavily Windows focused, and kind of two major components to it. LDAP and Kerberos. LDAP for the kind of user lookup and the information, and then Kerberos for the authentication, with a light sprinkling of some Microsoft magic in there to kind of glue them all together. And so with that, you had kind of a variety of things that had to happen. Your Mac was bound into Active Directory, which meant it had a computer account effectively and could interact with Active Directory, look up records and objects and things like that. Requires the user to be in the domain. So there's some organization and some other stuff here, which is actually pretty good. Active Directory allows you to have much more complex organizations and to be able to manage those and have sub-admins and all these kinds of good things. And then this kind of goes without saying, but it does require Active Directory. So to have Active Directory in your environment typically requires a bit of a knowledge level, a skill level to be able to manage it, set it up, configure it. Active Directory has a lot of moving pieces to it, which can be very, very powerful, but also can require some effort to keep in working order. AD had some problems, specifically if you've been trying to use it with DEP authentication and things like that. Active Directory itself is primarily an on-premise technology. You run your own domain controllers, and while you can put these into cloud services, you could put them into Azure, you could do things like that. Probably no sane person runs a domain controller that's publicly accessible to the world. A couple of reasons for that, but what this means for you as a Mac or an Apple admin is that at a DEP enrollment stage, it gets a little bit more complicated to either authenticate as that user or to do any sort of actions against Active Directory. You get a bit of a chicken and the egg problem there. If you're not on the network, how can you reach a domain controller with Active Directory that's on the network? Multi-factor authentication is difficult. It's by no means impossible. Smart cards work quite well with Active Directory and some things like that. But some of the more modern options with push notifications and things like that aren't necessarily available to you in these environments. And they're certainly made more complicated. Another major, maybe not issue, but just something to keep in mind with Active Directory is the fact that other services need to connect to Active Directory directly, need to have some sort of persistent LDAP connection or some way of constantly being able to phone home, identify users, authenticate users, whatever else, and interact with that. So all of these tend to make it much more complicated to work in a more modern environment. And so as we're going forward and over the last few years, you've probably heard some of these terms: SAML, Security Association Markup Language, Security Assertion, Markup Language. We'll talk about that very briefly here in a little bit. OAuth, which is similar but not directly related to SAML, and then OpenID Connect, as these have been kind of trending ways of getting authentication from Okta, Azure, maybe another identity provider, and allow it to be shared across multiple services and multiple users. gratuitous keynote transition there. So with these protocols, ideally we can at least make Active Directory go away or at least minimize it. In most cases, it's unrealistic to believe that Active Directory is going away for most organizations. As you're still going to have it for legacy applications, maybe your Windows systems, whatever else. However, we can at least put some of these other protocols, OpenID Connect in specific, in front of it. Those are public facing, able to be accessible by your Macs and iOS devices without necessarily having to be on a network, and give you a lot more of a modern authentication process. So before we get too much further, because this will become important as we talk about some of these protocols, it's important to kind of understand the difference between authentication and authorization. All right, we can bring up the dictionary definition of both of these. Authentication is specifically proving who you are. It's a username and password. It's a multi-factor device. It's somehow identifying yourself beyond a doubt. And so that's authentication. But authentication is not the same as authorization. Authorization is once you've proven who you are, that may give you certain rights and abilities. So in a particular example here, if I sign in to the login window at the Mac, that's a form of authentication, providing a username and password, and the Mac itself is authenticating me as a specific user. However, that doesn't necessarily mean that I can do admin actions or not. That's part of authorization, and that would be depend on group membership. If I am a member of, in the case of a default Mac OS installation, Group 80, the admin group. So two separate pieces there. The authentication is strictly the aspect of username and password effectively, but the authorization then is what you can do with that. So if you want to kind of boil this down, authentication is who you are, but authorization is what you can do with that. Now, this becomes important because we talk about specifically OpenID Connect. These kind of operations are broken apart. OpenID Connect only deals with the authentication part of it, whereas then the authorization part is handled by OAuth. In many cases, the authentication part will then go down to an identity provider. You may be using Okta, you may be using Microsoft Azure, Ping, OneLogin, Google, Yahoo. There's a number of identity providers out there, and you want to make sure that they are the only things that understand your username and password. They're holding all the authentication. But your various web services, SaaS services, anything else that you might want access to, those can get that authorization. So we'll show you how that's done here in a little bit. So to start off with SAML, this is probably the single sign-on technology that you're most familiar with, especially if you're a Jamf Pro customer and you've set up single sign-on, you have created a SAML connection. So it's focused on SaaS, software as a service, and it's not very applicable to native applications. This is one of the reasons why when we were looking at Jamf Connect and how do we authenticate you to these cloud identity providers, we specifically did not work with SAML because they would have required some sort of back-end web service to be available. SAML itself is fairly complicated. That's not necessarily its fault. It's doing a complicated job. However, it does mean that as an admin, you may have to jump through a few hoops. If you set this up on Jamf Pro, you've been through that. It requires a certificate, some metadata files, a couple of other things that go into there. And it is a little bit more laborious than maybe it should be. Commonly used, Jamf Pro, self-service, lots of other, this was kind of the first single sign-on protocol to be used for a variety of enterprise applications. If you go to the Microsoft, kind of the help sites, they've got a little Azure SAML flow. We're not going to spend much time on this, but you can see it kind of goes back and forth to a couple of different things between a user, the application service provider, the identity provider, and then back and forth. And we're going to give you a little bit better example of kind of this interaction as we get into OpenID Connect here in a little bit. Here is something that you probably haven't seen much of unless you've had an error. And this is an actual SAML assertion right here. So at the end of what happens with SAML, SAML is not at all involved in the authentication of the user. That's typically handled in a number of different ways to your identity provider. But at the end, you will get a SAML assertion. So this is XML effectively that determines what you can do, maybe what rights you have. It's got an issuer associated with this. kind of lets the other web service know what you should or should not be able to do based upon an authentication that you did somewhere else. So this is the heart of what a SAML request is. It's not real user friendly for an admin if you're troubleshooting. You've got some IDs, you've got some URNs in here, so you have to kind of pull those apart and get an understanding of it. Important to note, and the big difference between SAML and OpenID Connect is it doesn't have any concept of user information. SAML is strictly focused on just the authorization piece. What rights do you have? It doesn't have your name. It doesn't have a lot of other pieces about this. And so that's another reason why we've primarily focused on OpenID Connect, which specifically adds a lot of that in. Here's the SAML setup example, again, straight from Jamf Pro. So if you've gone through the SSO setup, you would see something that looks very similar to this, as you can see here. OAuth. OAuth started with Twitter. It's a little bit older than maybe a lot of people realize. It is now kind of morphed in. OpenID Connect is commonly combined with it, but it's been around. Primarily started with more of a consumer focus to begin with. Part of that was at Twitter. They wanted a way for you to sign into Twitter and then be able to sign into other services without having to type your password in again. So this was the beginning of some real thinking about how to make a consumer SSO service. And that has morphed into what you now see today with functionality such as sign in with Apple, where you're able to sign in with your Apple ID, the service that wants you to sign in, doesn't even know your username and password. In some cases, doesn't even know your email, right? Sign in with Apple is really good about making that very anonymous if you'd like it to. But you can still then continually prove that you are that same person that first showed up. And so all of that goes back to some of this original work that was done here. So it's related, but not based on SAML. They kind of share some similarities, and it's solely focused on the authorization, not on the authentication part. So OAuth doesn't care where you put your username and password or how that gets validated, whether it's multi-factor or something else. It just cares that once you've been identified, once you've authenticated, then you can go the rest of the way. So OpenID Connect comes in, and this provides a common authentication layer that's built on top of OAuth. So it kind of adds this other pieces in. Supports web-based and app-based authentication, specifically for Jamf Connect. That became very interesting to us because we needed a way to have authentication without worrying about where it came from, where it's being hosted, and the rest. Keep the complexity down. And we wanted that in a native app on the Mac. And so not having to have a website and services and everything else built into this. Again, much like SAML and some of these other technologies that we've talked about, it's very much designed to protect the identity, share as minimal information as possible, just enough to get you into the service, get the service configured with what it needs to know, but then keep everything else separate from that. Here's, if you go back to the Microsoft documentation, they've got another handy little web chart that looks like this, kind of goes through the OIDC flow. And you'll notice it's got a lot of similarities to the SAML flow. There's some basic concepts that both have together. This is what a OpenID token looks like. Instead of having a SAML assertion, OpenID primarily works with JWTs or JSON web tokens, which are signed bits of base 64 URL encoded text that then has some attributes, some claims, and some other things in it. We'll show you that in a little bit so you can get an understanding of kind of how to troubleshoot it, work with it, see what's being shared, and how the flow works together a little bit better. But this is the end result of what an OpenID authentication brings, is this OpenID token, which you can then pass on to the other service. Lots of places embraced OpenID Connect, Okta, Azure, Google, Ping, OneLogin, Yahoo. You can set up an OpenID Connect identity provider on Yahoo if you'd like to. Salesforce, lots of them out there. It's quickly become kind of the newer way of doing this. Again, reduce complexity from SAML, and then even more importantly for some of the things that might be doing is it's got this concept of an ID token that has some user information in it. So we'll show you that shortly. So real quick, let's go through an OpenID Connect flow, and you'll get a bit of an understanding here. So we've got kind of three pieces in play here. We've got a Jamf Pro server in the upper left-hand corner. We want to make a connection to that and do some admin work, perhaps. You've got Azure in the upper, or excuse me, Okta in the upper right-hand corner. That's your identity provider. And so how do you get all these pieces together? Well, for the user, you're going to go to your laptop. and you're going to open up a web browser and you're going to go to the Jamf Pro. Well, when you go to Jamf Pro, it says, well, I don't know who you are. You could be anybody. Let's identify you and make sure that you can authenticate correctly. So Jamf Pro will actually redirect you to a sign-in page. So when you see this, it's coming directly from Okta, at least the bottom half, under anything under connecting to Jamf there, is coming directly from Okta, and it's going to authenticate you directly to Okta as an identity provider. This way, Jamf Pro has no understanding what your username or password might be. Doesn't need to know what multi-factor services you might have. All of that is completely abstracted away from Jamf Pro as a service. And that's the beauty of kind of separating out this authentication from the authorization part of these operations. Jamf Pro doesn't have to know, doesn't have to be aware of Duo, doesn't have to be aware of Octopush or some of these other services. Instead, it can just get an ID token or an access token from Okta and then do what it needs to do. So you may do a variety of different things to authenticate yourself. Again, multi-factor. We'll show you some of that with Fido here in a little bit. And when you're done, you're going to get a token. Now, there was no easy clip art graphic for token. So in this case, we've used a ticket. If you are familiar with Kerberos, and again, if you've done any work with Active Directory on the Mac over the last 15 years, you've probably run across Kerberos. And with a little bit of hand waving and some squinting, a Kerberos ticket is fairly similar to a access token from a OpenID Connect operation. So they're kind of blobs of data. There's got some cryptographic signatures and some other stuff in there to validate who they came from. And they're able to then be shared with external services. And that external service can then use that as your ticket to entry. It's a little bit different in that there's a lot more encryption going on in the Kerberos side, whereas on the OpenID Connect, it's purely just signatures. But in the end of the day, you get to a very similar place. So that token gets generated by signing into Okta. That token then gets sent back to Jamf Pro. There's a redirect that's done in your browser. You can kind of sometimes see the URLs change. That's because you're getting redirected from Okta back into the original Jamf Pro instance that you were trying to connect to in the first place. And when that's all done and that ticket gets there, in this case, a token for OpenID Connect, that token can then be sent back to Okta by Jamf Pro to say, hey, do you validate this? Is the signature correct? This can be done offline, can also be done directly back to the identity provider, something called an introspection endpoint that you can use. Jamf Pro says, are we good? Okta says, thumbs up, let's go. And now you're actually signed in and you can get your dashboard. So a little bit of a visual representation for how an OpenID Connect workflow happens. And with that, let's do a couple of quick demos so you can kind of see some of this in action. And what we've got here is we've got an app called Jamf Connect Configuration. And you don't have to be a Jamf Connect customer. You can download our installer, and you'll be able to go through the process and understand how OpenID Connect works. So can download this. Again, don't need a license. You're able to kind of fill out some things. I've just picked Azure as my identity provider. And inside Azure, I've created a new application. And when you do that, you get a client ID, so you can just plug that in. And then we can go right over here to test, and we can just click OIDC. This will actually bring up a login window so we can see what we're doing here. And click Joel. This is going to prompt me for my authentication here. So I'm going to hit 14. I'm going to look longingly into my phone. So Face ID goes. And now I've successfully authenticated and I have tokens. So with these tokens, I've now got a great way for being able to use this. I can go into here. I can grab this ID token right there, and I can hop over here to a web browser. And there's a couple of sites. We'll start off with jwt.ms, and I've been told the kids call it JOT. And you can slur the JWT together. You can just paste this in, and it'll actually decode this token for you. And there's three basic parts of this token. Up here in red at the beginning is the header. This says it's a JSON web token. It's using an RSA-256 algorithm to sign it. Here's a key ID that's referenced. Here's the actual payload of the token. You can see this in kind of the darker blue. And this covers, here's my name. Here's maybe some groups that I'm a member of and some things like that. Some roles I might have. All of this is contained. So this is your user record in a very portable, signed format that you're able to send to these web services they can ingest this, they can trust it because it is signed. And at the end, it's kind of, since it would be just random information, there's a signature here that can then be cryptographically validated. So we've got a question about F5. I'm not specific about F5, specifically about how they handle OpenID Connect, but any identity provider or any service that says they can act as an OpenID Connect provider should act in a very, very similar way. In which case, it'll be functional with the Jamf Connect configuration app. And in fact, if I go back to here, you can see also that there's an access token. This is used for kind of what it says, to specifically access the service. Again, it's typically cryptographically signed, so you can prove that this is in fact valid, and usually only has a validity time of a few minutes to maybe even less than that. There's also a refresh token. This allows you to get new access tokens. Since the access tokens time out pretty quickly, the refresh token can be stored, keychain, maybe as a session cookie in your browser. And when you go back to that service after having logged out, it'll let you log immediately back in because the refresh token can be used to get a new access token. So pretty standard stuff in here. If you want to play around with whether your service like F5 or something else might happen, you can go into this and you'll be able to, instead of Azure or some of the other ones that we have built in, you could use a custom identity provider. And when you use a custom identity provider, there will be a discovery URL down here towards the bottom. That you can put in your well-known endpoints. With any OpenID Connect provider, there should be a well-known endpoints document, just some JSON that says where your token endpoint is, your authorization endpoint, these kinds of things. And with that, as long as the identity provider is fairly OpenID Connect compliant, we should be able to do the exact same thing and show you the cookies there. So I've got another little app set up, and this is another little test app that we use for testing some of our things. This is specifically configured with Okta, so I can sign in here with my Okta authentication, and it's going to send me a push. So I'm going to get that on my phone. There we go. Yes, it's me. So if I hit this, this then goes back to Okta, completes the multi-factor, and again, I get some ID tokens. So I can copy those out really quick. JWT.ms, this is a Microsoft-specific site, I believe, although it will work with any OpenID Connect tokens. But another site that you might want to try is JWT.io. I can paste this token into here, and you get a little bit of a different, but effectively the same information. Here's the payload, here's the things that it might be dealing with, here's the header for it, and then the signature down at the bottom. So it gives you a good idea of playing around with this. This is a helpful thing to do when troubleshooting, specifically what information your identity provider might be sharing. Can also let you get into some of the weeds about configuring claims and other pieces with this. So with that, we're going to hop back into the slides real quick, just so you have it in the recording. Again, the first app that I was working with was Jamf Connect Config. That's part of the Jamf Connect download you can get if you request a trial and things like that. And then the two websites that you can use to decode those tokens, jwt.io and jwt.ms. And again, both do very similar functionality, so take your pick on how you're doing it. And with that, we're going to move on from OpenID Connect specifically to Fido. So Fido stands for Fast Identity Online. It's got a number of different tools and other things that are in there that comprise this total package. So you're able to go in, use Fido Alliance and Fido Keys to kind of provide for a better user experience as you go through your process. So without further ado, we will get into this. I will say that we are members of the Fido Alliance. Jamf is. We've joined just in January because we believe so much in the protocols and the ability that will bring us as we go forward. So really, really cool stuff there, but we're biased. So if we seem overly excited or overly positive about Fido, it's not just because we believe in it. It is because it's the best protocol out there going forward for some of this multi-factor work. So let's get into this a little bit. So Fido is very focused on the consumer, has a high degree of anonymity. So you're in there trying very heavily just to be anonymous. It's designed that you could have one security key, one Fido key, goes by a couple of different names, Authenticator. And you may have The ability to sign in to, let's call it GitHub. GitHub can do FIDO authentication. And maybe you have 2 accounts on GitHub. You can use the same FIDO key for multi-factor for both of them. The important thing to keep in mind, though, is you will be generating different keys on that FIDO key. There's no way for GitHub to understand or to in any way figure out that you're actually the same person, even though you're coming in through 2 different accounts into that service. So that's a very important part of this, very focused on the consumer side again, and on privacy and being anonymous as you're going through it. Growing adoption, you may have heard a lot about FIDO recently. Apple recently has been adding it into Safari. Microsoft and Google have been using it for a while. If you are an Android user and you're using your Android device to sign into your Chromebook or something else like that, maybe you're not the target audience for this seminar, but I'm sure you're out there. If you are doing that, you're probably using a FIDO operation. Google has a couple of different ways of doing this, but their newest ones all use FIDO for that process. Microsoft has really embraced FIDO as well. Microsoft Authenticator has some FIDO aspects to it. You also can use it for Windows Hello for Business, as that is fully FIDO compliant and allows you to authenticate to a Windows 10 service, or Windows 10 computer, excuse me, with a FIDO key. So some really cool stuff, lots of growing interest and usage of that. Real quick, from a high level, FIDO allows you to create ECC keys. So these are public-private key pairs. ECC is elliptical curve cryptography. While you can do a variety of different types, the most common one is P256, or a 256-bit elliptical curve key. ECC keys are more compact. So if you're familiar with RSA, public and private keys, and you've heard like 2048-bit and things like that, ECC is a much different setup. So 256-bit is a very good level of security right now for ECC keys. So don't be thrown off by the fact that it's a lower bit length. Each time you go to a new web page, as I mentioned before, you will get a new key on that authenticator. So there's no way to correlate. It's really good for the consumer, makes it a little bit more complicated for enterprise environments. One of the things that we're hoping to see, and there's already some work on this, to make FIDO keys a little bit more enterprise friendly. When a key is created, when you associate the key with your account on the page, the public key is then sent to the service, the web service. That is stored with your user account. Your private key never leaves the device. In most cases, this is hardware encryption, like a secure enclave, something along those lines, and you're unable to export those keys. So otherwise than that, it's a fairly common PKI operation where you then use a private key to sign a bit of data. That bit of data gets sent back to the original website. And that way the website can then prove via cryptography that you in fact have the private key that was associated with that public key. The signature matches that private key, so you must be that user. And it's using that to sign in, as opposed to any sort of alphanumeric username and password as you go through there. FIDO keys can be a variety of different types of hardware, Bluetooth, NFC, USB. There's even a few Lightning ones, or at least one out there. I don't know if there's a second one. But all of those are transport mechanisms for doing effectively the same thing. FIDO does have a lot of kind of acronyms and names and other things associated with it. So as kind of a quick primer, FIDO 1, which was the original protocol, had something called U2F, or Universal Second Factor, which was the idea that it could be used as a second factor for any sign-in. But you still needed to know a username. So not bad, but just that the user might have to type in a username as they go through this process. FIDO 2, Universal Any Factor, that's UAF, and you can actually do full zero keyboard auth, and we're going to show that here very quickly as we sign in to some identity providers using FIDO key. Again, with the focus on the anonymity and the protection of privacy, the individual keys themselves, the individual pieces of hardware or software, don't have any sort of identifiable UID or anything else on them. So it's very hard to try and say, just because this same manufactured key signed in twice, that there's any correlation between that, or if they're at all the same user. And in fact, if you go into the FIDO spec, there is particular attention paid to the fact there's something called an attestation key, which is a private key, a certificate that's stored on the authenticator that then verifies that it's this make, model, and those kind of things. And you have to have at least 100,000 devices in the wild using that certificate before you can change it. So again, there's a lot of focus on ensuring that it's very, very hard to try and triangulate back that this user signed in here and this user signed in that, and they're coming from the same FIDO key, so they're probably the same person. All right. Some keys have biometrics. Those are some of the newer ones. I have one here with me that's a biometric key that we're going to be using for the demos. But most of them, I think all of them, have to have something called user presence. If you've seen these on the YubiKeys, which are probably the ones you've run across so far, there's a little disc that you have to touch that proves that there's actually a human on holding the device or interacting with the device. And that's a bit of an anti-phishing and a security consideration there to ensure that just because you have your security key plugged in or turned on, it doesn't mean that any website can use it. You as the user have to physically interact with it to prove that you want this operation to occur. So it's another good way of ensuring a high degree of security for this process. Here's some sample keys. You got anything from smart cards. They can be accessed over NFC, for example, and become a FIDO key at that point. Over there on the left, you've got a variety of ones from Phaeton. Those are USB and Bluetooth. I've got, I believe it's called a K33. That's the black square one in the middle. That circle is a fingerprint sensor, so that's what I've got here and what we'll be using for the demo shortly. What you may be more familiar with is kind of center right. That is a YubiKey. I believe it's a 5A, and that's USB connectivity with NFC as well. You can kind of see the radio waves above the Y there. And that's kind of maybe what you think of when you think FIDO key. YubiKey also has another new one that's the bottom right corner that has a lightning connector on it. So you're able to use that with iOS devices to be able to do authentication there. All right, so real quick, let's go through a quick Fido flow, kind of show you some of the pieces. Three kind of major components. There's a relying party. This is the website or the web server that you're trying to connect to. There's the platform. This would be your Mac or your iOS device. And more specifically, it's probably the web browser that you're using. While you can have apps use Fido natively, what you're probably going to find in the wild is mostly websites going through web browsers. So the web browser is the platform. That's the one that's getting the information from the website and then issuing the commands over USB, Bluetooth, or whatever else to what's there on the right, which is your FIDO key or your authenticator. In between the relying party and the platform, that communication is handled by WebAuthn. WebAuthn kind of call a couple different things, and that's effectively JSON going across there. So that goes to the platform. The platform then uses, in the case of FIDO2, something called CTAP, Client to Authenticator Protocol, and CTAP uses CBOR for encoding, which is compact binary order representation, I believe. And that's just a way of compacting the information as tightly as possible so that it can go across limited connections like Bluetooth or NFC or something along those lines. On Mac OS, most of the major browsers support this now. So you've got Chrome, you've got Edge, that's the wave in the middle if you're not using that yet, Firefox. And recently, within the last couple of months, Apple has added this into Safari, which is really cool because now you've got a variety of ways of using FIDO authentication. Important to note, if you do get one of the Bluetooth authenticators, and we encourage that because personally, I think it's going to get a lot more traction if users don't have to go plug things into the devices. There may be situations where you want a physical connection. Obviously, there's some jitteriness about Bluetooth. We can get into the protocol over some drinks, and I can explain to you why that isn't as big of a concern. However, if you are going to use a Bluetooth authenticator, it's Chrome or Edge that support Bluetooth. Safari does not. I think it's coming in Firefox. I haven't checked on that a little bit. If you're on iOS, there's two browsers that I know of. There may be more, but Safari now supports it for NFC and Lightning. And then that Lion on the left is Brave, which is another browser. That was the first browser on iOS, I believe, that supported FIDO authentication in there. So some cool stuff there. One of the things you still have to keep in mind, something that I also hope gets addressed as FIDO popularity grows, is that you do have a little bit of a chicken and the egg scenario here. Before you're able to sign into Okta, for example, with a FIDO key, you have to register that FIDO key with your Okta user. So that does require signing into Okta the first time with a username and password, registering the key, and then you can use it from then on for future authentications. So just something to keep in mind, and I think some opportunities for some improvement and some maybe more enterprise-friendly focus as we go forward with this. So a little bit of a demo. Let me go over here to Chrome. So I've got Chrome set up. Here I am at an Okta page. Let me just refresh this, and I will just sign in as my username and password, except I get a security key. So I'm going to take my security key, my Bluetooth one, hit the Bluetooth button so it starts broadcasting. I get a green icon on it. I put my finger on the device, and now I've been authenticated in. So that was a FIDO authentication directly into Okta without actually having any sort of password involved. So, but if you remember, I mentioned earlier on, there's something called UAF, or Universal Any Factor. So if I go over here to Azure, and this may be an Azure window that you've seen before where you're able to put in a username and password, I can now go to use another account, and down here is sign in Windows Hello or security key. If I click on this, it now does a similar look for my Bluetooth key. I hit the Bluetooth button next to it. It's going to start blinking. I now put my finger on it. I have now signed fully into Azure. I'm here at my Azure portal where I could, add new apps or whatever else that I need to do. So I'm fully signed into Azure without ever having typed a username or a password. And I've done it in a very cryptographically secure manner. It's not just a 12-character alphanumeric password, but it's a full-on ECC key pair. So this is really, really cool because it's not often that you have a situation where you can both increase security and the user experience at the same time as you go through this process. So this is one of the reasons why we're as excited as you hear us about FIDO and the things that it can do. As you know, if you're a Mac admin, if you're an IT. So thank you very much for your attendance. Hopefully this gets you excited about OpenID Connect and FIDO authentication. We'd love to have you play around with those and see more of them. So if you have any questions, you can scan that QR code. The marketing folks tell me they don't know if anybody's done that, but there is a QR code there that you can scan. So that's great. Or you can send an email to info@jamf.com and we'll direct it to the right place. So with that, thank you very much for your attendance here, and we hope to talk to you in the future. See ya.